Hi guys, how you doing? We're going to go over an activity here, which is interpreting confidence level. And we want to know, like, first of all, what does it mean to be 95% confident? And this activity is kind of going to show us right here. It's the meaning of the confidence level. So we're going to this applet. I'll put the link on the slides. It's a confidence interval applet. If you can mess around with this. So let's take a look here. So we're going to set the confidence level to 95% and the sample size to 5. All right, so let's go right to the applet right here. Here's the link, but I'll put that on the slides. So we're going to set the confidence level to 95%, and the sample size is going to be at 5. So let's move that down. Okay. We're going to click Sample to choose a simple random sample and display the resulting confidence interval. So remember, what we're doing in this case is we have a sample, and then we're going to go and infer to a whole population. So this is just regarding the sample. So we have right here a sample size of 5. And we're going to go and press sample right now. All right, so we have one confidence interval right here. All right, it's displayed as a horizontal line segment with a dot representing the sample mean in the middle of the interview. So that's my sample mean right there. And the population mean is right that green vertical line right there. So we're a little bit away from the population mean. It didn't quite hit it, but came really, really close. Okay. So the true mean is the green vertical line. Does the first confidence interval capture the true mean? So let's go to right here. It says, does the first confidence interval capture the true mean? We're going to repeat this 10 times and sketch what you see to the right. How many of the intervals capture actually the true mean? All right, so right here, even though we didn't actually, this point estimate didn't actually capture it, the line hit the true mean. And this is what's called right here, this whole interval actually did hit the mean. And this is the point estimate, and to the left of and the right are that's the margin of error to the right and margin of error to the left. So this actually hit it right here. Let's do another one. Yes, 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 no. Okay, so that's the first one. On the 7th one, right, is did not hit the actual true population mean, or why don't we just call it the true mean? It did not. Okay, let's do 3 more. 8, 9, 10. There we go. Okay, so right here we had a 90% hit rate right here. Okay, so that's what happened right here. We had a 90% hit rate. How many of the intervals capture the true mean? 9 out of 10. Okay, so right here, now we're going to go to the next one. Say 9 out of 10. Reset and then take a total of 100 confidence intervals. Sample 25 4 times. How many out of 100 captured the true mean? Is this surprising right here? So right here, we're going to take 100 confidence intervals, and that's just going to be 25 of them 4 times. How many out of 100 capture the true mean? All right, so let's go back. Reset, and we're going to do 100 of them right here. So we're going to say that means that there's 25, 25, 25, and 25. There's 100 right here. All right, so this right here. So what happened is 94% of these samples captured the true mean right here. That's the population mean. So these are, each one of these things right here, these are all samples. And so we developed a confidence interval from these samples. In 94% of them, the confidence interval captured the true mean. It hit the true mean right here. Okay? Is what happened right here. So right here, let's answer this question. Reset and then take a total of 100 confidence intervals, sample 25 words. How many of the 100 capture the true mean? Is this surprising? Why? So right here we had 94% capture of the samples captured the true mean. This is not surprising. And why is it not surprising? Well, the confidence level was set at 95%. So we'll just say that because the confidence, sorry about the handwriting there, confidence level is at 95%. Okay. Let's go on. Watch your confidence intervals as you drag the confidence level from 95% to 99%. Don't reset. What happens to the intervals when the confidence level is increased? Why does this make sense? Okay, so we're going to change from 95 to 99, and we want to look at the intervals right here. So let's go and do that. 95, 97. What's happening right here? So we're at 95 right here. Now we're going up, up. So it looks like right here, as we raise the confidence level, the confidence interval increases. So it's like we would call that in an algebra sense direct variation. As I increase the confidence level, the confidence interval increases, right? Okay, so let's take a look right here. So as we increase the confidence level, the interval gets wider. So we hit the mean more often right here. So what we're going to say is, as we raise the confidence level, the confidence intervals widen. Why does this make sense? Well, let's think about this. If we're more confident right here that we're going to hit the true mean, that means we have to right here widen. Let's look at this right here. If we're more confident, we're 99% confident, that means we better widen all these intervals because we have to have a better chance of hitting these hitting the true means. If we widen all these intervals, then in this case, only one of them did not hit. Now, if we lower it right down to 95, okay, then in this case right here, we lowered it. We had 94 hits out of 100. It's not showing them all right here, obviously, but we had 94 out of 100. But if we widen it up right here, there's a much better chance that we're going to go and, so we raise the confidence level. That means we better be sure that almost all of them, 99 out of 100, are going to hit this true mean. All of these samples will actually hit the true mean. So the reason why is if we are more confident, we have to be more sure that the intervals capture the true mean. All right, now, next, step 5, it says, reset, then sample 100 times at an 80% confidence interval. How many intervals capture the true mean? All right, so now, we're going to reset, and we're going to go 80%. So this is going to make the intervals much more narrow because we're less confident right here. Okay. And we're going to go and do this 100 times. There we go. Okay, so actually, as you see, as I lower the confidence level, these intervals become much more much more narrow because we're less confident that it's going to hit this true mean right here. Okay, so in this case right here, we had about a hit rate of 78% right here. Okay, and again, your answers will vary. But in our particular case, it was about 78%. Okay. Now, we're going to interpret the confidence level. Okay. So what I'm going to say is right here, and this was in your slides and in the other video, if we take many samples, we expect about 80% right here. If we're talking about an 80% confidence interval right here, we expect about 80% of the resulting intervals resulting confidence intervals to capture the true, and we're talking about mean right here. Sometimes you'll be doing this with proportion, but it's going to be mean. So how you're writing this, if we take many samples, we expect about 80% of the resulting confidence intervals to capture the true mean. Okay? And this is actually also, this interpretation is just as well in your slides. Let me show that to you right now. So you can... Okay, so just fine tuning right here, that interpretation right here. If we take many samples of the same size from this population, about 80% of them result in intervals capturing the true mean. Okay? So if we take many samples right here of the same size from this population, about 80% of them result in intervals capturing the true mean. So that's why right here we took many samples, right? We took, in this case, 100 samples. And it was all the same size. Sample size was 5. And we found out that about, in this case it was 78, but it was about 80% of these samples resulted in intervals that actually capture the true mean. So that's how you that's how you interpret this properly. All right, so I'm going to say that once again. If we take many samples of the same size from this population, about 80% of them result in intervals capturing the true mean. Okay. Step 6 says, now we will see what happens when we adjust the sample size, change the sample size from 5 to 50, and sample of one interval. And sample for one interval, sorry. Then change it to 250 and sample for one interval. What happens to the interval when the sample size is increased? So now what we're going to do, I'm going to reset, and we're going to go and just take, we're going to increase right here to from 5 to 50 first. So remember, when you have a bigger sample size, the standard deviation decreases, right? It gets much more tight. So let's take a look here what's happening. All right, so look, the confidence, as I increase the sample size, the confidence interval decreases. It gets much smaller right there. All right, and look right here. All of them are much smaller. All right, now, if we increase it even more, let's go up to the next one, which was, I believe, 250. And there we go. So right here. Now we're going to go sample. Look how small that confidence interval is. Tiny right here. All right, this is a very, very, very narrow interval right here. So as we increase the sample size, the interval gets much, much, much smaller because, remember, the standard deviation decreases. All right, so just remember that the confidence interval is created, like the formula which we'll learn later, is created by the standard deviation. So just remember that right here, as we increase this sample size, this confidence interval gets much smaller. All right. All right, so that does it right there. So let's go and just kind of, the interval narrows as sample size go up, we expect less variability. So we're going to say the interval narrows as sample size increases. Remember that variability decreases. So that's the reason why. Therefore, giving you a smaller interval. Okay, let's go and kind of just summarize everything, all the important ideas right here. Okay, first of all, the interpretation of a confidence level. Let's see here. So we're going to say right here, as we right here, just as we right here, as we if we take many samples, many samples of the same size from this population, about blank percent of them result in an interval, result in intervals capturing the true true, and then we're going to go and put blank right here because it depends. If it's a mean, then we put mean. If it's a proportion, we put proportion. Or maybe in very rare cases, you could be doing a confidence interval for medians or something like that. Okay, so it depends what parameter you're talking about right here. So that's key. That's right here, the interpretation. Put that as 1. Part 2. We're going to be doing right here, what affects margin of error? Now, we didn't really talk too much about margin of error yet, but what happens right here, when we have a confidence interval, if you look back to right here, and this actually decreases right here so you can see a bigger one right here. Actually, let's make it way lower. There we go. All right, so a margin of error, what you have in a confidence interval is you have a point estimate that's right in the middle, and then to the right is your positive margin error, to the left is like the negative margin error. So the margin of error right here is like basically half of the confidence interval. So right here, let's talk about what affects margin of error. Well, if you increase confidence level, then therefore right here, your margin of error is also going to increase. Okay, and this is, remember, the entire interval. That includes also the entire interval will increase too. Because remember, margin of error is just half of your confidence interval. Okay, so if you increase sample size, remember when we increased sample size, the interval shrunk, it got narrower. Increase sample size, then that is going to lower your margin of error, your interval. Remember, it made it much more narrow. All right, so that's part 2. Part 3, margin of error doesn't account for bias at all. These are 2 different things. All right, we'll talk about that later. But just a definition of that. Margin of error does not account for bias. Remember, we talked about bias last chapter. That was when you're just consistently missing your true parameter. You're just consistently getting to the, maybe all much more positive or much more negative. But margin of error does not account for that. Okay, let's look at this last example, and I think we'll be done right here. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said that she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA, the true mean GPA, I would add that right there, for all students at her school. Now we're going to interpret the confident level right now. Okay, so we're going to just go follow this sample, this interpretation right here. If we take many samples of the same size from this population, about, in this case right here, we have a 90% confidence interval right here. So we're going to say right here that about 90% of the resulting intervals, 90% of, why don't we just say 90% of them result in intervals that capture the true, in this case we're talking about right here what? The mean GPA, the true mean GPA for all students at our school. Okay. Good enough right here. If we take many samples of the same size from this population, about 90% of them result in intervals that capture the true mean GPA for all the students at the school. All right, good enough. You could have probably just said for the true mean GPA. That would have been okay too. Explain what would happen to the length of the interval if the confidence level were increased to 99%. Well, remember, if we increase the confidence level, the interval decreases also. All right, just remember right here. Increase right here, what's happening? It's getting bigger, 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 bigger. Okay. So right here, we're just going to say it would widen because the margin of error increases. So just remember, in your head, you don't have to write this down, but in your head, if we are more and more and more confident that this interval is going to capture the true mean, then we have to widen that interval out to make sure that it actually hits the true mean. All right, how would a 90% confidence interval based on a sample of 200 n equals 200 compared to original 90% interval? All right, so our original sample size was 25, if you recall. So basically they're saying if we have from 25 to 200, what the heck would happen? Well, remember, when we increase the sample size, the confidence interval became narrow. Because if we increase the sample size, the margin of error decreases. So right here, just to remind you, right, if we have originally 25, let's reset. Right here, if we have a 90% confidence interval right here. All right, so here's originally 25. Now we're going to increase this all the way up to 200. Let's see the difference. Much smaller right here. So let's go and do it. So we're going to say right here, it would be more narrow because increase in the sample decreases the margin of error. Okay. D, describe one potential source of bias in Ellery's study that is not accounted for by margin of error. So let's look at this again. Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. State their GPA aloud. Based on the responses, Ellery said that she was 9% confident the interval from 3.14 to 3.52 captures the true mean. So the key right there is for all students at our school. It says right here, state their GPA aloud. That's a source from bias right here. Some students may not tell the truth. Okay, so one potential source of bias is students may not tell the truth when stating their GPA aloud. Okay, that is one source of bias right there. Okay, all right, guys. Talk to you soon.